this tutorial, we'll cover what Incisor extensions are, how to build extensions, and basic examples of extensions use cases. Along with its rich library for creating interactive user experiences, Incisor also offers a powerful set of tools for streamlining and optimizing the production process. Incisor extensions let you write scripts for the Incisor inspector and environment, making it easy to integrate custom workflow tools directly into Incisor. Since the inspector is built using the same core Incisor API, creating custom tools works seamlessly with the same reliable API you use for standard projects. To get started with extensions, click on the Template Library tab and select Project Extensions from the drop-down menu. From here, you can see our list of available extension examples. They are designed to walk you through various implementations of Incisor extensions, including custom menus, custom panels, file I/O, pop-ups, project connection actions, publishing actions, and various UI components. It's recommended to check these out after the video. Two easy methods of adding custom workflow tools to your project is by adding custom menus and adding custom panels. Menus are a purely functional option, with all visuals being preset for you by Incisor. The other option is panels, which can be customized both functionally and visually, including the ability to add buttons, search bars, drop-downs, collapsible menus, and much more. You can quickly get started with your custom menu by going to the project extensions in the template library and choosing Add Custom Menu. This will immediately set you up with a working menu with a pop-up alert. You would then just add your functionality to this. You can also add a custom panel quickly with the template Add Custom Panel. You can then add whatever additional functionality and visuals you may want to this panel. It's important to note that while Incisor extensions are compatible with both TypeScript and JavaScript projects, extensions are exclusively written using JavaScript. To take a more in-depth look at Incisor extensions, in this tutorial we'll be building extensions from scratch. So first we're going to select the Add Blank Template option. Incisor will then prompt you to name your new extension in the pop-up's text field. After selecting OK, you will notice a new JS file appear under Project Extensions in your project's utilities directory. Opening this file, you can see Incisor has already laid out our standard two-part system to extensions. There's the main definition section where you will put your class definitions at the top of the file, and at the bottom of the file will be your run before init section. This section is marked by the code tags run before init begin and run before init end. This is where you will put your runtime commands. We'll start with menus. Creating a new menu with Incisor requires a new class to hold our menu item's functionality. In this example, I want my new menu item to take screenshots of my project, so I'm going to name it Save Screenshots. Then moving to our Run Before Init section, we're going to create an instance of our new class and create our two menu items, one a standard menu item, the other a submenu item. This is done with the Add Inspector Menu Item function. This function takes the parameters location, object owning our callback function, and of course the name of our actual callback that we want to call when the menu item is selected. You'll notice our location parameter is an array. This allows you to put your menu item at whatever depth in the Incisor menu you choose. Each string is the menu and preceding submenus you want your menu item to be in, with the last string being the one actually calling your callback. If the menu or submenu you listed doesn't exist, Incisor will automatically add them for you. Going back to our class, let's actually implement the two function callbacks for our items. The first is going to be our standard menu item that will take a screenshot of our inspector. We'll set our destination for the screenshot and create the corresponding directory if it doesn't already exist. We'll take our screenshot using Save Inspector Screenshot and then use an alert to inform our user that the action has been completed. Next, for our submenu callback, we'll do a similar thing. However, for capturing our screenshot, I'll actually show you two methods we could use. If you've noticed, we've been using NCE throughout this script instead of the usual NC. This is because while NC is our primary accessor for Incisor, Incisor's extensions instead uses the accessor NCE. NCE stands for Incisor Extensions, and while it does share a lot of the functionality as NC, keep in mind NCE runs in its own context within the inspector, so it doesn't behave exactly the same as NC. If there's something you need to access from the Incisor project itself, you have to use nce.project.nc. You can see us using NCE's method for screenshot capture here with nce.saveProjectScreenshot, and just below that, the same thing is done, but what would have been nc.saveScreenshot is now nce.projectnc.saveScreenshot. In this example, you can also see that we've used the async and await keywords. Because Incisor extensions incorporate functionality that interacts with external processes, using the await tag can be necessary to help ensure that the given commands have completed before the subsequent JavaScript actions. If you use an incisor extensions function that is itself marked as asynchronous, it is generally a good idea to mark the function you are using it in as async and to use the await keyword when calling it. Now let's check out our new menu items. You can see how Incisor treats menus and submenus, and when we select one, you'll see how alerts appear to the user. Thanks to the alert, we know our screenshots are in the screenshots directory. Next, we'll create our own custom Incisor inspector panel. Our first step will be creating a new class that extends the inspector panel class. Be sure to include a constructor that calls the superclass constructor, which in this case takes the name of the new custom panel. Incisor panel is a class that extends SceneObject and provides the basic elements for an inspector panel. Inspector panels include all the members needed to define borders, menu bar features, and standard panel functionality. Panels have two main customizable sections, the header scrolling panel section and body scrolling panel. These contain layout stacks that will define where the content for the custom panel is placed. In our sample, you can see we kept our header scrolling panel simple with only a UI text being added to its body stack. Meanwhile, there are several built-in GUI items placed within the body scrolling panel. Some of the items placed in the body of the example incisor panel include UI text, UI collapsible stack, UI drop-down menu, UI buttons, including link buttons and graphic buttons, and finally pop-ups, including the preset yes/no query pop-up and the text query pop-up. Each item in the body scrolling panel is connected to functionality defined within the inspector panel class. Before going more in-depth with our functionality, let's add our custom panel to the Incisor GUI by going back to our Run Before Init section and using Register Inspector Panel Definition. This makes it available for users to select from the panel type dropdown. Now let's take a closer look at how our panel functions, focusing first on the UI collapsible stack and how it uses runtime project analysis to dynamically populate its contents. We've added a trigger callback to the stack so that whenever the user expands it, our function grabObjects is executed. Inside this function, we begin by clearing the stack to ensure a clean slate before adding new scene objects. Next, we retrieve all scene objects from the main scene by calling nce.projectnc.mainScene.getDescendants. You'll notice we're using the Project NC reference again. By referencing Project NC, we ensure we're accessing the project's descendants rather than those of the inspector. Once we've gathered the scene objects, we'll iterate through them, creating a new UI text element for each object using its name. Each new UI text is then added to the body stack of our UI collapsible stack. Now that we're done coding our collapsible stack's functionality, let's check it out in real time. You'll see that I can close and open our collapsible stack, and every time I open it, I can see the objects in my hierarchy reflected in the body stack of the collapsible stack. Next, let's examine the drop-down menu, which also interacts directly with the scene. The drop-down's callback Make New Object allows users to create new scene objects based on their selection. User input is captured through the UI menu item parameter, and a switch statement handles each menu item option, enabling specialized functionality for our menu options. This example allows us to create different kinds of scene objects based on user input. If we test our drop-down menu, you can see the new object of our choice pop up in both our hierarchy and the live view. When creating a new scene object, we again use nce.projectnc to access the proper graphic asset and the proper parent for the object, the main scene. After recreating the new scene object, we generate a corresponding UI text element with the same name and add it to the collapsible stack. Now let's look at our first button, Objects of File button, and the functionality it provides with File I/O extensions. In this example, we're exporting all scene objects to a text file. We begin by defining a destination path for the output file, then use nce.fileio.createDirectory to create the directory if it doesn't already exist. We again retrieve the scene's descendants, but this time instead of adding elements to a UI component, we concatenate each object's name into a single text string with a new line. Once complete, we create the file, if it doesn't already exist, and write the concatenated text to the file using nce.fileio.writeTextFile. Now let's test our File I/O button. When we click on the button, we can see a file generated in the top left corner, and if we open it, we'll see a list of objects that match what's in our hierarchy. Custom Inspector visuals, File I/O, and Project Access enable you to build many time-saving tools for specific project needs, but extensions provide other avenues for creating productivity tools as well. Commands can be invoked when the inspector connects to or disconnects from a project. Use nce.addProjectConnection callback and nce.addProjectDisconnection callback. Functions can also be triggered right before or after a project is published, making publishing procedures fully automatable. Simply use nce.addPrePublish callback and postPublish callback. In our example, we implemented a postPublish callback that compresses the screenshots and text files generated earlier. The functionality for this callback also resides in our panel class. The function first sets the location of both our files and checks if the directories to be zipped do indeed exist, along with checking if the zip files already exist. If the files exist and we haven't already zipped them, it will compress our files using nce.fileio.compress. Incisor extensions can also be used to run external commands via the nce.runbash and nce.run command functions. At the very end, we have a run command directory response being printed to an alert so the user can see that the files have been zipped. Project extensions create functionality specific to a given project. If you want to apply the same functionality to all Incisor projects, simply place the extension scripts in the global extensions directory inside the Incisor application support folder. This folder can be found either in the user directory or it can be accessed from within Incisor by clicking on the Incisor logo in the top left corner and selecting Open Application Support Directory. This concludes our tutorial on extensions within Incisor. If you'd like to explore this example more, you can find it in the Project Extensions folder in the Incisor Example Gallery. Check the link in the description to download this example and for more tutorials, and feel free to leave questions and feedback on Stack Overflow and our subreddit. Enjoy creating with Incisor.